Hey everybody, Mr. Judson here. Boy, so this must look familiar. I'm back to where I was last spring trying to do videos from home. And this will just happen for today. I'm still trying to recover from the surgery, but everything should be back to normal next week. So our main focus for today is we want to be able to evaluate limits algebraically. Remember, we had three ways to do limits. We had a numerical method. That's where we just plug in numbers close to whatever our x value is from both sides and see what we get. A second method is a graphical method. And today we want to look at an algebraic method. And really, this is what we want. We want to look for algebraic methods to solve limits, mostly because it's the quickest way to go. Now, I told you guys something. I don't care how you do a limit. You know, you can show me an answer any one of these three ways, and it will show that you understand what you're doing. You know, I just think this tends to be the quickest way. If I have to plug in lots of numbers, that may not be a quick way to do things. All right. So how would I solve this algebraically? Well, really, the idea is you want to look for an equivalent function to this thing right here. Okay, equivalent function to this. And so if I was to factor this, this would equal the limit as x approaches 2. Let's see, this would be x times x. Two numbers you multiply to get 8 and subtract to get 2. Got to be 4 and 2. And I want to get a positive 2, so that means positive 4 minus 2. And then I've got an x minus 2 in the denominator. And so what I see is that I've got a fraction here that can be simplified. I can cancel this. Now, remember last year we said the only time you can cancel is when you have things that are being multiplied. You can't cancel parts of things that are being added or subtracted to something else. Okay, so we still have to pay attention to that. But here, this factor is being multiplied times x plus 4, and so we can go ahead and cancel those. And so now our limit would read like this. The limit as x approaches 2 of x plus 4. And I no longer have an expression that's undefined, which means I can go ahead and do direct substitution. I can just plug that in and get 2 plus 4, which is 6. And that would be the answer to my limit. Now, just to make sure that this whole idea is very clear to us, what we're saying is if I was to graph y equals this expression right here, right? If I was to graph it, y equals x squared plus 2x minus 8 over x minus 2, and then I looked at my graph to see as x gets close to 2 from both directions, what would the y values be getting close to? And we're saying right, excuse me, we're saying right here, this is what we're getting close to, y equals 6. Okay? If I wanted to graph this, okay, so if I wanted to graph this, you know, I'm going to go back to the original function, not this function. I want to go to the original one. I'm going to go ahead and put that in and then graph it. I'll just go zoom option 4. And there's what I get. And I want to see what happens as x gets close to 2. I can't see that on my graph here, so I'm going to have to adjust my window. So let's do this. Let's go from 0 to, I'm just going to double this number here. 15.8. Actually, let's not double that. Let's just leave that as 7.9. And for my y values, I'll do 0, 2, and I'll double this one, 7.6. And then we'll graph that. So see how there's a hole in the graph there? That's where it's undefined. If I plug a 2 in, I get 0 in denominator and we're undefined. And what I want to know is what are my y values getting close to. So if I go to trace, and I just kind of arrow out, let's see, I got to back up because there we go, there's my cursor. First I want to come towards 2 from the smaller side. So if I watch those y values, you know, what are they getting close to? Well, it looks like they're getting close to 6, but we're not hitting 6. Once I get a little bit larger than that, if I arrow back, same thing, I'm getting closer and closer to 6. And so visually I can see that. If I wanted to go 1.99999, I'm going to trace really close to 2, I can see that my y-coordinate is really close to 6. So I did it algebraically, but I'm kind of verifying my work graphically as well. By the way, I don't know if anyone has figured this out yet, but there actually is a limit feature on your calculator. If I went to, let me show you something else that's nice about the calculator too. I don't want to type this function in again, so I'm going to go back to my y equals. I'm going to arrow up so it's highlighted, and I'm going to do, see the cut, copy, and paste right here in green? I'm going to do green diamond copy. And so I've done it just like copied into a clipboard, just like on a computer. And so now I'm going to go back to my home screen, and I'm going to do F3. I want to calculate something. And look at option 3 there, limit. There it is. And so now I'm going to paste my function back into there. I'm going to go green diamond, and then over here the paste option. And so I didn't have to retype that whole thing. So that's kind of a nice feature. There's a syntax to this. You have to make sure you punch things in correctly. So I've got my function I'm taking the limit of. I now need to tell the calculator as what variable gets close to what. And you do that with commas. So comma, as x gets close to comma 2, and then a close parenthesis for that limit command. And so there it is. My answer is 6. So it's kind of nice if you have some even problems that you want to check and those answers aren't in the back of the book, you could go ahead and do that real quick. All right, let's try another one. All right, you guys go ahead and try this one. You want to find the limit as x approaches 1 of x cubed minus 1 over x minus 1. Go ahead and give it a shot. So I think the words they use in our book is that it says to write a simpler function that agrees with the given function at all but one point. It's kind of the same thing as looking for an equivalent function. Okay, so they changed the word slightly in our newest edition. So probably the main issue here is how do I factor x cubed minus 1? I guess what I would hope is that you guys at least remember it can be factored. The question is, what's it going to factor into? Here's what I always remember. It's going to be something like x plus 1 or x minus 1 and then something else. Some kind of quadratic expression. And what I'm hoping is that it cancels with this. So my guess is it's probably going to be x minus 1. And now the real key is, do you remember what goes here? I think I remember it just because I teach this stuff every year, but chances are you probably forgot it. So how do I find that out if I'm not really sure what to do? Well, on our calculator we have factor command. So I could factor x cubed minus 1. There it is, there's those factors. And so now I can go ahead and proceed with this. If I didn't have a calculator available, which guess what? Now that I've showed you how to do limits, if our first test is all about limits, yeah, you don't get this calculator to use on our first test. I don't know how that's going to work yet, but we need to take the test without our TI-89. Usually what I do in the classroom is on test day, I'll just check out the yellow TID force to everybody. And I don't know how that's going to work with this. Be honest, I haven't worried about it the last few days. So, but the other thing I could do is I could just do synthetic division. My coefficient here is a 1. There is no x squared term. There is no x term. And then there's a negative 1. And I'm trying to see if this divides into that evenly. So I would use a positive 1 for synthetic division. So I'd bring down the first number, multiply and add to the next. Multiply here, you get 1. Add to this, you get 1. Multiply, you get 1. Add to this, you get 0. So now I know it's x minus 1 times x squared plus x plus 1. Okay, so this now equals the limit as x approaches 1 of x minus 1 times x squared plus x plus 1 over x minus 1. And so we could look at this and say those factors cancel. Now what I have is the limit as x approaches 1 of x squared plus x plus 1. Now, real good question here, and this is something we need to all pay attention to. These are little details that we want to make sure we catch. How often do I have to write down this limit until I actually plug the 1 in and get my answer? And the answer is you have to write this until you do plug the 1 in and do that direct substitution piece. The moment you do direct substitution, that's when you can quit writing this. I couldn't do direct substitution here because if I plug in a 1, 1 minus 1 is 0, and that's undefined. And you'll figure this out real quick. Almost all limits are going to give you 0 in the denominator. Almost always. Because those are the ones that require a little more work to solve. On our homework page today, the first 40 problems are all direct substitution. Oh my gosh, how many of those do you have to do before you realize if I can just substitute it in, go ahead and do it? I'm not even going to assign those 40. We're doing direct substitution right here, and so we're getting that practice. All right. So now I can plug the 1 in, and so what I'm going to get is 1 squared, that's 1. Plug in a 1 there, and I got that 1, and so my answer is 3. There's my answer. If I want to check that on the calculator, so I'll clear this. I'm just going to go back up and get this right here and just do some editing. So this should be minus 1. And over here, this should be a 1. And then gone. That should be a 3. There we go. Answer is 3. All right, let's try another one. All right, so here's another limit that's a little more complicated than the previous two. You know, the previous ones, all we have to do is factor and see if we can cancel something and then try our direct substitution. This one, how do I factor this? Yeah, we're going to have to come up with another strategy. So it says here the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. So the strategy that we want to use here is, you guys remember last year, well, for years now, if you have a square root in the denominator, we usually say that's not okay. We have to rationalize the denominator. Well, what we want to do is we want to rationalize the numerator. Now, why do we want to do that? Well, because we don't know what else to do. You know, we're going to try something and see if something good comes from that. And actually it will. Sometimes this strategy might be rationalize the numerator. Sometimes it might be rationalize the denominator. What we're really trying to do is get this x to cancel in any way possible. And so when I rationalize, what I'm doing is I'm multiplying top and bottom by the conjugate of this. That's going to get rid of that square root in the numerator. And what I'm hoping is I'll be left with just an x, so it'll cancel with this right here. So square root of x plus 1, and then plus 1. So this is the conjugate of this right here. Remember that word conjugate just means like x plus 2 times x minus 2. Those are conjugates of each other. You get that middle term to disappear. And we know that whatever you do to the top of a fraction, you have to do the exact same thing to the bottom. Got to multiply by the same thing so that this fraction here in red is equal to 1. That's all we're doing is multiplying by 1. We're going to change the way it looks, but not its value. So if I FOIL the numerator, I'm going to get square root times itself. That's just x plus 1. And then I'm going to get a positive square root of x plus 1, and then a negative square root of x plus 1. So those two will add up to 0, and then a negative 1 times positive 1, that's negative 1. In the bottom, I'm not going to multiply this out because remember I said my goal is for that x to cancel, and so I want to leave it as two factors so that that can happen. Still have to write down the limit as x approaches 0. So now when I look at this, I see that 1 minus 1 is 0. And so now what I have is the limit as x approaches 0 of x over x times the square root of x plus 1 plus 1. And so now the x's cancel. I could have done both of those in one shot as long as I understand what's happening here. I didn't have to write it one more time. And now what I have is the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And now I could do direct substitution because I'm no longer getting 0 in the denominator. When I plug in a 0, I get the square root of 0 plus 1, which is the square root of 1, which is 1, plus 1, that's 2. And there's nothing up here, so there's my answer, 1/2. And again, we're saying that our y values, if I was to graph this function, the y values are getting close to 1/2 as x gets close to 0, and it's happening from both sides, not just one. It's got to happen from both sides. All right. If I want to just double check this on the calculator, I've already punched it in. There it is. Getting close to 1/2. Hey, one thing I want to just say to you guys, and I really do believe that most of you get this because I'm seeing it in your homework. But in the pre-calculus class, we're not getting it. We're not even close yet. When a teacher explains something to you, they're doing more than explaining. They're showing you, here's how you show your work for this problem, right? Here's the original problem, here's the answer. This is all the work that produced that answer. Make sure you pay close attention to that, not just in my class, but any class. You know, the goal of the teacher is to show you how to do the problem. And so if you just do what the teacher does, you're doing everything right. You know, on a test, if you showed your work just like this, you're doing exactly what you're supposed to do. And you're going to get it right. Okay? I just want to make sure that's clear for all of us. Let's try another problem. All right, so we're trying to find the limit as delta x approaches 0 of x plus delta x cubed minus x cubed all over delta x. You guys go ahead and try that. And you know, again, this is really important. Don't just sit there and go, I don't know what to do. I'll just wait for Judson. I mean, I can't stop you from doing that. But really, you should have it inside of you that, like, I want to try this and see if I can get it. If we don't have that desire to at least try and see if we can figure something out on our own, that makes it hard in life, you know. So try something, anything. See what happens. All right? You guys give it a shot. All right, so it kind of looks like I could factor this. I mean, I was just able to factor x cubed minus 1. 1 was a perfect cube. It'd be like saying x cubed minus 1 cubed. But there's not really a factor down here to cancel it with. So even if I could factor it, I'm not sure what that would lead me to. So without really knowing what else to do, I'm just going to multiply this whole thing out and just see what happens. Okay? I don't know what else to do, so that's just what I'm going to try. So I'm going to square this first. I'll multiply 2 of them. So when you do that, you square the first term, multiply the 2 and double it, and you square the last term. And then you multiply it by another x plus delta x. I'm just doing this down here off to the side so I could just write the answer down once I get it. So I'm going to take x times all 3 of these. So I'm going to get x cubed plus 2x squared delta x plus x, oh this should be squared, plus x delta x squared. And now I'm going to take a delta x times all 3 of these. So I'm going to get a x squared delta x plus 2 x delta x squared plus delta x cubed. And then I just got to add up like terms. So I now have the limit as delta x approaches 0 of, let's see what we get here. I've got an x cubed, 2x squared delta x. Here's another x squared delta x term. So 2 of those plus 1, that makes 3. So 3x squared delta x. And then I've got an x delta x squared, and here's 2x delta x squared. So you add those, you get 3 of them. So plus 3x delta x squared, and then I got my delta x cubed, and then minus this x cubed. Still have a delta x in the denominator. So I do see like terms here and here. One's positive, one's negative, they add up to 0. And when I look at what's left, every one of these has a delta x in it. So I could factor a delta x out, and I'm left with 3x squared plus 3x delta x plus delta x squared. All over delta x, and I still have to write down the limit as delta x approaches 0. I've got like a little piece of fuzz that's smearing everything I write. Great. Alright, so that divided by that equals 1. So I'm now no longer getting 0 in the denominator. So what I have now is the limit as delta x approaches 0 of 3x squared plus 3x times delta x plus delta x squared. And so there is no delta x here, so there's no place to plug a 0 in, so I just get 3x squared. I'm now doing my direct substitution, okay? Because I no longer get 0 in the denominator. I plug in a 0 here, 0 times anything is 0. And I'll plug in a 0 here and square it. 0 times 0 is 0. And so what I get is 3x squared. There's my answer. What's interesting about this is we actually just did a derivative without even knowing it. And you guys are probably thinking now, oh, wait a second. Judson said we're doing derivatives all semester. Does that mean we're doing nasty limits like this all semester? Well, you gotta wait and see. You gotta wait and see. We got a lot to learn here. But yeah, we just did a limit, or a derivative. We don't know what it means. We don't know why this is a derivative. We don't know what this relates to in terms of it being a derivative. So we've got a lot of stuff to learn, but that was our first derivative. And what that means is this idea of taking a limit as something gets close to 0 and working with it is going to be a pretty important idea to us. Okay? All right. That's what we have for today. Trying to solve limits algebraically, but just working with algebraic expressions. We're not going to see any trig in here. Guess what's coming next? How do we solve algebraically with trig functions? And so we'll tackle that next week, but that's what we need to do for today. So let me get you guys a homework assignment. All right, so here's our homework assignment. This is number 4 continued. We're in our 4th week. I think some people still haven't quite gotten this down. Most of you guys have. But this is our 4th week. Everything this week is due next Tuesday. For today, Thursday, we're doing page 71 and 41 to 57. So if you want to at least take a look at some of the problems prior to this right here, might be worth doing. It's all direct substitution, and I don't see the point in doing a whole bunch of those because it really doesn't happen that often. Like you probably won't see that on a test. If you did, you'd see one question. Everything else is going to be you either have to solve it numerically or graphically or algebraically. But it might be worth at least taking a look at. If you want to just do 1 or 2 and then just double check your answer in the back, you can do that. Okay. All right, so there it is. That's what we have. Let me just say one more thing. This gets people sometimes. The limit as x approaches 3 of 4. And a lot of times people think they can't do that because I can't do direct substitution. I can't plug in a 3. Well, remember, this is the equation y equals 4. And what does that look like? 1, 2, 3, 4, there it is. It's just a horizontal line. What are your y values getting close to along this line as x gets close to 3 from both directions? Well, they're not just getting close to 4, they're always 4, right? If there's no place to plug a number in, then the answer is just whatever's written there. And I think I saw a few of those with direct substitution that if you ran across it, you might all of a sudden ask yourself a question. But yeah, my y, if I'm graphing y equals 4, then y always equals 4, no matter what you're getting close to. And so the limit is always going to equal 4. Doesn't matter what we're getting close to down here. All right, there it is. That's what we have for today. I'll see you guys next week. I should be back at school and hopefully feeling better. Feeling pretty good right now, just still a little sore. Moving kind of slow, but next week we'll get back to normal. All right, you guys take care. Be safe.